Today we're gonna learn about wireline information test. Before that, we have to know about Dream Steam test, or shortly we can say DST, is a temporary completion which enables information evaluation and record the natural characteristic from the reservoir or zone of interest in either open or case hole application. Also, in other ways, we can say procedure to determine of the productive capacity, pressure, probability, or extent of an oil or gas reservoir. So now we can say in general about wireline information test that the pressure measurement is requirement by inserting power into the power hole well and performing a mini drawdown and build up by withdrawing the small amount of information fluid and then waiting for the pressure to build up to the information power pressure. The measurement can be provide information pressure along the power hole.
In the simplest form, the drill stem test tools run on either drill pipe or tubing, consist of flow control valves, a fluid sample chamber, an inside pressure recorder, one or more packers to isolate the zone being tested, a perforated anchor for flow to enter the tool straight, a temperature recorder, and a pressure recorder. As the tools are run into the hole, the increasing hydrostatic pressure of the mud column is recorded by the pressure gauge. When the tools reach the depth of the formation to be tested, the packer is set against the wall of the hole or casing, thereby isolating the pressure of the mud column from the pressure in the test zone. Pressure is measured at the very bottom of the tool string and also within the tool string itself. And so the gauge now will record the pressure imposed by the hydrostatic head and any squeeze pressure developed when setting the packers. A flow valve is then opened and the formation fluids are free to flow into the low pressure drill pipe. As the fluids fill the drill pipe, the pressure increases. This is the initial flow or pre-flow period and is usually a short duration, typically 5 to 10 minutes. Its purpose is to relieve any built-up in pressures that may have occurred in setting the packer or the packers or any supercharging of the reservoir due to the mud filtrate invasion. The control valve is then closed, and because the fluids can no longer flow into the drill pipe, the pressure recorders can see the increase in the pressure. The recorded pressure normally approaches the original formation pressure. This is the initial shut-in pressure. The shut-in period typically lasts for 30 to 60 minutes. The control valve is then opened once again for a second more important slow period of the test. This part will last for 60 to 180 minutes for an open hole test and up to 8 to 10 hours for a cased hole test. At the end of this second and the final flow period, the fluid sample is collected and isolated in the sample chamber. This final flow period is followed by a final shut-in period, and which should last for about twice as long as the final flow period. This gives the value of the final shut-in pressure. Any produced hydrocarbons are then reverse circulated out of the test string. The packer is carefully released and the tool is pulled out to the surface. Note that the hydrostatic pressure imposed by the mud column at the bottom of the drill stem as soon as the packer is released is reduced as the tool string is pulled out of the hole. At the surface, the pressure recording device is retrieved from the tool string to the alternating pressure drawdown and the build-up periods is analyzed. Of course, if the required information was not obtained, the test must be repeated. To avoid this costly remedy, it is now possible to measure the pressures at the surface while the test is being run. This provides immediate information on the quality of the test, an opportunity to analyze the data before the tool is retrieved, and the ability to terminate the test when sufficient data has been collected.
In many areas, hold conditions prohibit use of drill stream tests as temporary wellbore completions. In these areas and in others where the cost of the required numbers of drill stream tests for complete evaluation are prohibitive, wireline formation tests frequently are used in formation evaluation work. What is the definition of wireline formation testing? Wireline formation test uses a sonde that can be positioned at a selected depth in the formation to provide accurate measurements of pressure and fluid type, but with limited production data. The mechanism of wireline formation tests. Wireline tests are performed mostly in open hole using a cable-operated formation tester and sampling to ensure at depth while reservoir communication is established through one or more pressure and sampling probes. A wireline formation tester is a sample chamber of up to several gallons capacity combined with pressure gauge. The test chambers are forced against the borehole wall in a sealing pad, and the formation is perforated by firing a shaped charge. Fluid is collected during sampling and pressure is recorded. Following sample collection, shut-in pressures are recorded as they build up with time. The objectives of wireline formation tests. As we know, well tests are conducted at all stages in the life of a reservoir: exploration, development, production, and injection. At each of these stages, tests are performed with set objectives using specific hardware and design options. The first information that we can get through wireline formation tests is the formation fluid samples and pressure profiling along the wellbore to determine the fluid context. At the exploration stage, wireline formation test is performed to measure pressures and collect fluid samples. It is used to measure the static pressures of all the permeable layers of interest. Pressure versus depth plots help to establish the formation fluid gradients and identify the fluid context in the reservoir. Besides, we can control local production and vertical interference, or in general, interval transient tests at distinct points along the wellbore. In the production phase, the objectives of testing shift from flow evaluation to reservoir monitoring, data collection for history matching of reservoir stimulators, and productivity tests to assess the need for stimulation. Wireline formation tests are performed to check the skin resulting from migration of fines to the near wellbore region and to assess the need for acidizing to remove those fines. Wireline formation tests can use to determine permeability barriers and high permeability stress along the wellbore. Besides collecting fluid samples, wireline formation testing can be used to determine permeability. The pressure were recorded and the pressure build-ups at the end of sampling can be used to determine permeability. Lastly, through wireline formation testing, we can determine the horizontal and vertical perms and also their distributions along the wellbore. It can be determined using equations and graphs as shown below.
Now we will discuss the difference between drill string tests and wireline formation tests. Drill string tests can be performed in both open and case hole environment with a single or a dual bagger, while wireline formation tests are widely used in exploration or appraisal work and reservoir development projects. Wireline formation test is quick and inexpensive, unlike the other tests. In some areas where hole condition prohibits the use of drill string tests as temporary wellbore completions, and others where the cost of the required number of drill string tests are prohibited, wireline formation test is frequently used in formation evaluation work. Drill string tests provide exploration teams with valuable information about the nature of the reservoir and determine the fluid present and the rate at which they can be produced. One wireline formation test determines permeability barriers and high permeability sticks along the wellbore and also horizontal and vertical bump along the wellbore. The radius of investigation of wireline formation tests is normally smaller than conventional well tests and dry string tests, but larger than coals and logs. Their radius of investigation is within tens of feet radially and vertically along the wellbore.